Hello everyone, I'm Sashank. I'm from College of Engineering, Anna University. I'll be presenting our paper, Content-Based News Recommendation Engine using Hybrid BiLSTM-ANN Feature Modeling. It is co-authored by Samya Sanagavarapu. This is an overview of our presentation. So recommendation systems. Today's generation depends on the web for everyday news headlines, with a recent study indicating that about 5,000 news articles are published every day on an average at various media on the internet. Recommendation systems are information filtering systems that aid in navigating through the textual content to find related articles. The recommendation system introduced by us does not require to store user history. Rather, it just uses the current article that the user browses and recommends articles based on that particular content. So we built a neural network that helps to categorize articles into different classes. We use the weights of this optimized neural network in order to create a feature identification matrix, which can be then fed to KNN. The KNN determines the similarity between the feature identification matrix and determines articles closely related to the article under study. The cosine similarity is used as the similarity measure, as it is beneficial for sparse data and it can map these data at high speeds and low complexity. This is the system that we have designed. We have designed a hybrid categorization model which makes use of features such as hypernyms, and words, and uses a BiLSTM-ANN model. We can then use the prediction of the ultimate layer and the forward propagation values at the penultimate layer to calculate the gradient. We use the gradient calculated to introduce a feature identification matrix that is fed to a KNN model. We determine the similarity between the feature identification matrices for the training set articles, and we determine closest articles based on cosine similarity. So the first part is feature engineering, which involves extraction of hypernyms and hypernyms. These help add to context to the word in the articles and help to derive a word ontology. We use a hybrid categorization model, which uses BiLSTM to model the words in each sentence and to determine their codependencies. The ANN model models the vectors of the hypernyms and the hyponyms along with the word ontology. By modeling the hypernyms and hyponyms together, the linguistic meaning of each word in the given context is determined. This is the architecture of a standard BiLSTM model which we use. It can map words in both the forward and reverse direction, helps to determine what is the next word in the context as well as the previous word in the context. This is done by remembering the cell states and activating the values. We use ANNs to map the hypernyms and hyponyms. Hypernyms help to determine the generic class of a specified word. This is by determining a necessary relationship between the word and the class. Hyponyms, on the other hand, determine words which have a similar linguistic relation to the word under study. By including both hypernyms and hyponyms, the articles can be categorized into multiple classes. ANNs help model the vectorized form of these hypernyms and hyponyms. Then we create a gradient class activation map by using the activation probability at the ultimate layer. We calculate the gradient of this activation probability with respect to the forward propagation value at the penultimate layer is it. We determine this vector and then we apply a rectified linear unit activation function to remove the negative values and keep only the positive values to create a feature identification matrix. We pass it to a KNN model which uses cosine similarity to group the articles. System implementation. We use a data set which comprises of news headlines as well as their articles. We group the articles into 6 categories by annotating them as business and economy, entertainment and sports, criminal and legal, lifestyle and fashion, political, and science and engineering. Each category of articles in the training set has 500 articles. So there are total 3,000 articles in the training set, whereas there are 600 articles, 100 articles from each category for the testing set. The first step in pre-processing involves tokenization and removal of stop words, and then we assign a POS tag. This tag helps us to determine the hypernyms and hyponyms of the particular word. This can be curated by using NLTK's WordNet tool. We can see that we tag the word following as adjective, and we calculate 5 levels of hyponyms and 10 levels of hyponyms for that word. Categorization model. We use the following parameters to build a hybrid BiLSTM-ANN model along with a meta classifier, which helps to relate both the BiLSTM as well as the ANN models. The first step in finding out the categorization, finding out for the recommendation engine is to determine the final layer as well as the penultimate layer. Find the ultimate layer, we reverse the layers and iterate through it to find out the output layer with a shape which is not equal to the number of categories. This is because we go with the categorization model, and the ultimate layer would always have the number of nodes which is equal to the number of categories. Once the penultimate layer is found out, we pass the vectors of each news article through the classification model. We get the forward activation values at the final layer as well as the penultimate layer, as we can see here, which is the con outputs and the predictions. We calculate the gradient of the con outputs and the predictions, which is grads. We cast it using ReLU. ReLU helps to eliminate the negative values and help to only accumulate the positive values. This ensures that only vectors which positively affect the classification of the article into a particular category is taken into account. All the vectors which do not affect it positively are removed. Once it is done, we calculate we cast the convolution outputs as well as the gradients. We calculate a gradient vector. Once the gradient vector is calculated, we reduce it by calculating the mean to create a feature identification matrix. We pass this feature identification matrix to a KNN model, and we set the number of neighbors in the model as 6 based on experimental results. Cosine similarity is used for calculating the distance. Results. So this is the training plot for the categorization model. We stopped training the model at level at epoch 8 because it reaches 99% training accuracy. This model, which uses level 1, 2, 3 hypernyms, has the fastest convergence, and hence it is being used. This is the visualization of similar news articles for a particular news article, which is at Golden Globes after party star upload merits. We can see how each data point represents any other article along with their categories. This is an example of an input headline which is given along with the output headlines that the model returns with their similarity scores. This helps to determine the relative association between the input headline and each of the output headlines. Coverage analysis. Coverage is the percentage of items the recommendation model is used to identify on the testing set. For example, for a particular category, lifestyle, it can be seen that 116 articles from the testing set is of category politics. So this shows that politics is closely related to lifestyle. We can also perform this coverage analysis by identifying the cosine similarity between the various categories. This is the average likeliness of the recommended articles to be determined by using the measure cosine similarity. The values present show how much each article is related to each other article in the category by using cosine similarity as the distance measure. It can be seen that crime has the highest cosine similarity on an average with all the other articles taken into account. It has a cosine similarity of 0.73%. Conclusion. We introduce a hybrid categorization model and then extend it to perform recommendations by using gradient class activation maps. We calculate the gradient class activation maps and then perform cosine similarity based KNN modeling to understand how recommendations can be given. We use coverage analysis to analyze how the similarity varies across different categories and which categories are related to each other category. This method is independent of the user's history and facilitates ongoing processing of suggesting articles. As future works, we would try to use NLP techniques such as named entity recognition that can help to remove any existential bias. We could also use robust classification models that use big data, that process big data in real time. We thank chats of ICIEV 2021 for giving us an opportunity to present our paper. We are open to any questions. Thank you.